All right, we're going to do this little video on a currency exchange and talking about applications of proportions. So Bill is traveling to Canada. He has 400 US dollars and wants to exchange this to Canadian dollars. The current exchange rate is $1 to $1.28 for Canadian. How many Canadian dollars will Bill receive? Now, the big key with proportional reasoning is just making sure we're staying consistent. So when we're thinking about this problem, what we are comparing. So I'm a huge fan of writing things down. So we're comparing US dollars to Canadian dollars, right? So I'm thinking like top to bottom. Everything in my numerators is going to be about the US money. Everything in the denominators is going to be about Canadian. Now we're also comparing the exchange rate against Bill, right? So I like to think like this is my information here. I can set it up inside this box. So the left ratio is the exchange rate. The right ratio is all about Bill. If you're having trouble setting up proportions from application type problems, write this stuff out. It'll give you positioning. So we know when we're talking about the exchange rate, $1 US to 1.28 Canadian. Okay, US is on the top. So this is the exchange rate. So $1 US is 1.28 Canadian, right? Canada's on the bottom, US is on the top. Now when we go over to the side of Bill, we know that Bill has 400 US dollars. US is on the top, so 400 goes on the top. That leaves my only unknown value in the Bill Canadian spot. And that makes sense because how many Canadian dollars will Bill receive? Once we have this set up, we've got the ratio 1 over 1.28 equals 400 over x. Now I can solve this like a normal proportion. I cross multiply. Denominator of one times the numerator of the other. So 1x equals 400 times 1.28. That gives me x equals 512 Canadian dollars. And that's the basis of currency exchange with proportional reasoning.